Graphing a rational function with all of its steps. This is a great example for you to watch and pause and listen and take notes on. What we're giving you here in this example is a polynomial in the numerator. I'm just going to call this n of x, and a polynomial in the denominator, d of x. And I'm going to identify the degrees. Remember, the degrees are the leading terms degree, which in this case the degree is 2, and in this case the degree is also 2. So let's first identify the domain of this graph. So the domain of the function. What kind of numbers can you plug in? So I'm just going to erase this piece again. We're going to let the denominator not equal 0. So we say here's our denominator, x squared minus 1, and it cannot equal 0. So we're going to solve this equation for x. So we're going to undo. So we're going to add 1 to both sides. And then we're going to square root both sides. So x cannot be plus or minus 1. Every other number works. So it's all real numbers, except x cannot be plus or minus 1. So down the road, those are going to be where your domain restrictions are true. So now in part B, to find your vertical asymptotes, we're going to let the denominator equal 0. And you just do the same thing. Or notice that these are your vertical asymptotes, because those are where your domain restrictions are. So solving it for x, undo, and you get x equals plus 1 and x equals minus 1. So those are where your vertical asymptotes will occur. Then we look at the degree of the numerator and the degree of the denominator. If I go back a couple slides here to step 3, to have a horizontal asymptote, if the degree of the numerator equals the degree of the denominator, which this is the case for this example, then we divide their leading coefficients. So my numerator and denominator are both the same for degree. So my coefficient is a 2, and then my coefficient is a 1. So I'm going to divide 2 over 1. So y equals 2 over 1, or y equals 2. So that'll be where your horizontal asymptote is. Then we'll talk about x-intercepts. To find your x-intercepts, they are going to be the zeros of your numerator. So we go back up. Our numerator is 2x squared. So we're going to set that equal to 0. And solve it for x. So I'll first divide both sides by 2. And then square root both sides, and you get 0. So we have an x-intercept of 0, 0. And if you remember, this is also telling us that we have a repeated 0 with a multiplicity of 2. Y-intercept, let x equal 0 and solve for y. So we go back up to the function. We're going to use this function. Think of that f of x as also y. And we're going to substitute x into the function of 0. I'll scroll back down. Remember, this was my function. I'm just replacing it with a y. Then I have 2x squared over x squared minus 1. We're going to let x equal 1. Simplify it, 0 over negative 1 is 0. So we have a y-intercept of 0, 0. Then we can check for symmetry. So we would take that original function again that we have graphed in the, or circled in the red, and we test for symmetry. So here's my equation, y equals 2x squared over x squared minus 1. And we want this to have our original x equation, or our equation back, so we're going to replace this with a negative y. So negative y equals 2x squared over x squared minus 1. We didn't get the original equation back. Testing for y-axis symmetry, replace each x with a negative x. And we simplify that, and we get the original function back. So this does have y-axis symmetry. Last test is for the origin. We replace the y with a negative. Replace each x with a negative. Simplify it, and that's also a no. So you do not have symmetry about the x-axis or the origin, but you do with the y-axis. I'm going to wait on finding my additional points on step 7 and start graphing what I have. So here's my x-axis, here's my y-axis, and you can start from the top, you can start at the bottom of the steps that you found. So I'm just going to go back up to the top. The top identifies the domain, which is the numbers you cannot plug in for x, which are your vertical asymptotes of x equals plus or minus 1. So those are your verticals. So I'm just going to go a scale by 2 here. So make this a 1, a 2, and a 3. Negative 1, negative 2, negative 3. So I have vertical asymptotes through negative 1 and 1. So I'll label those as my vertical asymptotes, x equals negative 1 and x equals 1. Then I'll go back up to my next step that I found. My horizontal asymptote is at y equals 2. So then on my y-axis, I'm going to go up 2. So here's 1, 2, 3, 4. I'm going to go across 2. Here's y equals 2. Then I'll graph my intercepts. My x-intercept and y-intercept are both the same, 0, 0. So I'll create a point here, put it in purple, 0, 0. Well, that doesn't tell us a whole lot more besides our one symmetry. We have y-axis symmetry. So I'll keep that in mind. So now we have to just try some additional points around my intercepts and evaluate the function. So let's try 1/2. So when you evaluate the function, you're substituting 1/2 in. So y equals 2, replace the x with 1/2. And then we simplify that. Just going to grab a calculator to save us a little bit of time. So 0.5 squared times 2 divided by 0.5 minus 1. And we get negative 1. Now remember with that symmetry, we have y-axis symmetry. So if I go negative 1/2, that also has to be negative 1. So I graph those couple points. Over 1/2, down 1, left 1/2, down 1. What's going to happen in between these two asymptotes, looks like a little parabola that opens down. Then you want to try something like maybe 2 and see where the curves might happen. So try 2. Just kind of erase this work here in the purple. And you're evaluating the function now at 2. So you're replacing the x with 2. So 2 squared is 4. 4 times 2 is 8, over 1 is 8. So I graph over 2, up 8. And what you're going to get, if I find some additional points, there's going to be a curve right in here. And then again, there's symmetry. So there should be another point. If I change the x to -2, I should have also up 8. So -2, up 8. And sorry about that. And that's how the curve would look. You probably should graph a couple more points within these curves. Maybe try something like 3 and -3. I'll just do that quickly. So 3 squared is 9, 9 times 2 is 18, over 2 is 9.